Hi, this is Tim. Today we're going to talk about how to connect an encoder to a Micro 800 PLC. And this works whether you're using the high-speed counter in the Micro 850 PLC, or if you're using one of the high-speed counter add-on modules, say for a Micro 820. The setup's going to be basically the same. Please take a moment to like our video and subscribe to our channel. We put out at least one automation video a week. And also this is going to be probably a 3-part series, so that way you'll get notifications when we will put out the other videos. We're going to start off going through how to wire your encoder to your PLC and how to configure it in the Connected Components Workbench software. And then we're gonna take a deep dive into how this high-speed counter actually works, because really it is just 2 PLC inputs. But I hear a lot of misconceptions and just confusion about what's actually coming over those 2 PLC inputs. So we're gonna break it down and really talk about how the signal coming off of your basic encoder looks and how it turns it into what you'll probably have heard as a quadrature. And then how we can actually look at these transitions to figure out, one, the direction it's going, and also count the values. Probably in the third part of this, we're gonna make a ladder diagram that mimics what a high-speed counter actually does. So let's start by talking about how we're gonna wire an encoder. This is a basic encoder. This is a hollow shaft encoder that you would connect to, say, the back of a motor. And it is a 1024 count encoder. And what that means is it has 1024 little, probably notches, maybe etches in a piece of steel around a disc. And it has 2 sensors, an A sensor and a B sensor that are 90 degrees apart. In the second part, we'll go more through that. And then it has a Z marker, and a Z marker is triggered once per revolution. First, you need to determine how to wire your encoder. And in the case of this encoder, it has an open collector output, and that is probably one of the common signals that you will see. You'll see open collectors and then probably differential line drivers. Those 2 are the most common. So we're gonna wire this one for an open collector. And what that means is that it will be a syncing sensor. And even though it has a lot more wires than your typical sensor, our basic diagram from our syncing and sourcing video still holds true. So we have a syncing output. We're gonna use 2 syncing outputs out of this, the A channel and the B channel. So our PLC input is going to need to be sourcing. So this diagram right here can easily be modified to look like this. And I've also pasted our terminal in at the top. So we're gonna need to take 24 volt from our power supply and we're gonna connect it to COM0. And then we're gonna come off of input 0 and we're gonna connect it to the A channel. And we're gonna come off of input 1 and we're gonna connect it to the B channel. And then yes, there are some extra wires that you're gonna need to look at your particular encoder to figure out. But mainly from the general syncing sourcing part, we're gonna have this common that is gonna be taking these A's and B's to, which is connected to the minus of our 24 volt power supply. And that's what I have wired here, but instead of the encoder where I gotta sit here and do this the entire video, we are going to be using one of the PLC tools, SIM-EOCs. That's the encoder simulator for an open collector output. They're also available in a 5 volt TTL like you would use for a differential line driver. And I have it already connected up, and I'll put a link in the description that'll talk you through how to connect this, but it's exactly the same as this diagram right here. In fact, yeah, I mean A plus, B plus, and yeah, common. The only thing that I'm missing is you feed 24 volt power, and you could scratch that out and call it the encoder simulator. Now let's go through how to configure your high-speed counter in the Connected Components Workbench software. And we're gonna do it completely the right way first for everyone who is like, hey, I need to configure this super fast and then I'm gonna leave your video. But then I'm gonna go through some of the pitfalls and headaches that I did run into while I was configuring this because I couldn't find a lot of information on it. We're gonna start with a new program and we'll just call this our Micro 850 counter. And we're gonna go to controllers, Micro 850, and we are using a 2080 LC50 24 QBB. It's a version 12, so we'll select it and add to project. And then before we go anywhere, let's go ahead and configure our Ethernet We're going to be using 192, 168, 110, and a subnet of 255, 255, 255, 0. And then we're going to right-click Programs, and we're going to add a ladder program. And we'll go ahead and open that up. And we are going to click this instruction block up here and drag it down. And then just start typing HSC. And there is the high-speed counter instruction. So we're going to click it. And this instruction block here has everything that you need to get your high-speed counter going. If you mouse over it, it tells you the data types of each instruction that you're going to need. It kind of disappears occasionally, so you have to move back over it. We have an enable, which actually comes straight across. And then we're going to have an HSC command that is going to be an unsigned integer. So we're going to double click right here. And we're going to go ahead and add an HSC CMD1 for that high speed command. And it is going to be an unsigned integer, USINT. And we'll go ahead and select it. And then we'll mouse over it again. We see high speed, we see HSC app data, and that's going to be an HSC app. So we'll double click on this one. We're just going to create one that is called HSC APP1. And for the data type, it will be HSC app. And we'll go ahead and select it. Next, we have HSC STS info, which is an HSC STS file. So we'll bring it up, and we're going to make an HSC STS info, and that'll be a data type of HSC STS. We'll select that one. Next, we have the PLS data. Now, this was the one that really stumped me to start with, so pay attention to this part. Is we're going to create this PLS data, and it will be a data type of PLS, but you see behind it there, it says 1.1. Well, I missed that the first time, and the instructions are not really clear on what was missing. So we're going to bring that up, and we will make an HSC PLS, and this will be data type of PLS. And then we are going to, in the dimension column, put an open bracket, 1, dot, dot, 1, close bracket. And we're going to talk more about multidimensional arrays in a later video, but that's what that is, and we'll go through the details of it later. And we'll select that. And then we have one output on this, and that is going to be an STS, which is the status of this instruction. And trust me, that is a very important one to pay attention to once we get it going here. But it is going to be an unsigned integer. So we'll open that up, and we are going to create an HSC status, and that will be an unsigned integer. And for the basic ladder instruction, this is all you're going to need, but there are some super important values that you have to enter into this to make it work. So now we're going to open up our local variables, and then we are going to go to the HSC app1. We'll open it up, and we're going to change these initial values over here. So for the PLS, let me open this up a little more so you can see all of them. Yeah, that's got it. This PLS enable, we're going to put false. And then the high-speed counter ID, we're going to set to 0. Now, we're going to set it to 0 for the Micro 850 using input 0 and 1. And you'll need to look in the user manual to figure out the assignment for your particular configuration. And then our mode is going to be 8. And they do a great job of explaining this in the manual, so I'm not going to go long and far into it. But 8 will set it up for an AB quadriger encoder. So it's going to use input 0 and input 1. and it is going to make a quadrature counter out of it. And what that means, which we're going to go through more in the second video, is not only is it going to count every time that it goes up, it's also going to count every time it goes down. And then we're going to talk about how it uses the phase shift to determine direction, whether it should add and subtract. We're going to do that in the second video. Mainly for this one, mode 8 is going to give you that A, B. It's not going to give you the hold and reset, because I'm not using that in this video. But if you needed to hold your counter or you needed to physically reset it, then you would need to use the hold and reset. We're going to reset ours through ladder logic. Now our accumulator, that is going to be the value that our counter is counting. So now on to the next really stumbling blocks. So don't shortcut out of this thinking that you're done and you don't really care about these values, because that's exactly what I did, and I fought it for quite a while. Is you have this HP setting, this LP setting, the OF setting, and the UF setting, and those do have to be entered. And so for the HP setting, if you're just not concerned at all about the programmable switches and making it do things, which I'm not concerned about, I just want to look at the position, then go ahead and put the HP setting at 2,147,483,646. And that is one value less than this counter can count in the positive direction. And then set the OF, which is the overflow setting. I should have said that. The HP setting, that's the high point setting. LP is low point. Then we have the overflow and we have the underflow. Overflow is how high you're going to let that counter go. Underflow is how low you'll let it go. And we are going to set our overflow at 2,147,483,647. Now, if you're just like, whoa, I don't know how I'm going to remember that number, that is the limits of the double integer data type. And I'll put a link to a lesson that talks about all those limits. Now for our LP setting, we're going to set it at a negative 2,147,483,647. Again, I'm copy and pasting these values, guys. Don't think that you need to remember them. And then the other one, the underflow, needs to be one more than it. So it's going to be 2,147,483,648. And finally, there's one more value that you need to set. This HSC command 1, we're going to set it to an initial value of 1. Okay, there's one more thing, and this is by far the most missed thing that you must do to make this work. And I really wish that if you put the high-speed counter into a mode that needs high speed, they would actually put some warning up about this. But we need to lower the input filters on input 0 and 1 to make this work. So if we click on our Micro 850 and then we go down to embedded I/O, we're going to see these input filters here. And the default values are going to be too coarse to actually pick up the pulses of our high-speed counter. So this input 0 and 1 input filter, we're going to just drop down to the lowest value, which is 5 microseconds. And we're actually, in this video series, we're going to go through what this does. I'm not sure. This may be that fourth video I was saying that may happen, but this is an important thing to understand, because the reason for these are that normally you're trying to make a system more noise immune. So you don't want, little ripples of power actually signaling something. But in this case, we're going to be using really good shielding. We're going to be using really good power supplies and just really good wiring practices to prevent all that. And those little ripples are our encoder signal in this case. So we have to have those down. So now we're ready to download our program. So let's go ahead and download it. And if you need any help downloading your program or configuring your Ethernet connection or just general basic instructions, I'll put a link to this entire series down in the description. Okay, so it's downloaded. Also make sure that you're actually in run mode. And then we are going to start with 10 Hertz or 10 pulses per second on our encoder simulator. And we're going to put it in the forward direction, or we're going to make those go positive. And we're going to go here to local variables, and we are going to open up the HSC App 1, and our accumulated value is now 9541. Now, if you're looking at your screen and you're like, yeah, it jumped, but now it's not doing anything, this window right here, the local variable window, does not update if you just are sitting here still. And that's something that took me a while to figure out. But if you will just click on that cell, every time that you click on that particular value, it's going to update for you. And that's why I had the HMI here. We're gonna add the HMI into this in a little bit, just so we can see. In fact, I'm gonna go ahead and add that now. So I'm gonna go back offline, just so we can look here and I'm not having to click that button all the time, because I think that's probably that thumping is gonna get annoying in the video. All right, that makes it a lot easier to see here. I think you can see the screen. I sure hope so, because there will be a lot of voicing over if you can't. But right now our value is about 1600, and we're going 10 cycles per second. Now, if you're looking at this and you can see it, hopefully, you're gonna notice that, well, no, the tens place is incrementing way more than 10 a second. And yes, it is. It's actually incrementing 40 per second. And that's that quadrature part that we're gonna talk about in the second video. We can bring our frequency up to 100 cycles a second, and it's gonna start moving faster, and we can go up to 1,000, and it's gonna move even faster. And then finally, we can go to 10,000. And yeah, the numbers are flying up now. And we can reverse direction. Actually, we can stop first. I press it once, it stops. And then we press it again, and now our numbers are starting to go down. And I'll let it sit here and go down into the negative, just so you can see a counter can count positive, it can count negative. So now it's going negative. Also, let me just close in on this. And one thing I want to make sure you see is right now, I've got this on 10 Hertz. And we're going in the positive direction. Direction doesn't matter for what I'm going to show you here. But look at these inputs. And now I'm going to switch this to 100 Hertz. You see, they look almost solid. In fact, they have I'm not even sure the camera can pick up, they have a slight, very slight flicker to them. But then when we go to 1 kilohertz or 1,000 Hertz, these things go on solid. And then we can finally go up to 10 kilohertz, still solid. But when we go back to 10 Hertz, you're gonna see them blinking. And I hear this a lot. People are like, hey, I think there's something wrong with my machine. And of course, they always blame the part they don't understand the most. But they'll be like, hey, both input 0 and 1 are on solid. They're not blinking. And this was really a huge issue on like the Micrologix 1100, where it had the LCD display. This one is slightly better since it has the LEDs, but still, when they're blinking like that at a high rate, they're gonna look solid on. And that's something you just need to be aware of. The other thing that we need to talk about is, yeah, we've got this counter going along, and we are now, well, we're at a negative 700,000. Direction we're even going. So now we're going down, but let's say that we need right there to be 0. There's 2 ways you can do that. First, you could use input 2 if you configured your mode right to reset your counter, or you can do it through software, and that's what I want to show you here. So we're going to go back offline, and we're going to insert another rung. Actually, we'll insert it right below our counter, because this bottom one is just so you can see this value here. And I have button 1 on our trainer connected to input 8. So we are going to look at a direct contact, examine if closed. And we're going to go over here to our IO tab, and we're going to scroll down to digital input number 8. And then we are going to add an instruction block. And we are going to use a move instruction. And we are going to move, in this case, I'm going to move a 0. Now, you can move whatever value you want. And we are going to move it to the HSC App 1 dot accumulator. Then we're going to take another instruction block right behind that one. And it's also going to be a move instruction. And for our input, we're going to use a value of 4. And for our output, we are going to go to the HSC CMD1, which is that high-speed command. And what this is going to do is it's going to take what's in this high-speed accumulator, and actually the high and low preset also, and put them into that counter configuration. Now to get our counter back going, we're gonna need to switch this back. So we're going to go here and we'll go ahead and just add another rung. And we're gonna use the reverse contact, examine if open. And we're gonna look at that same button 1. And we're going to bring an instruction block down and use the move again. And this time we're gonna move a value of 1 into the high speed command. And I'm gonna go ahead and download that. Okay, we're going up. We've got 300,000 pulses coming up on 400,000, and we hit button 1 and it goes to 0 and it starts counting again. And actually, if we just go ahead and stop our counter, we're stopped at 214,000 and I hit that button, it's gonna take our counter to 0. So those are the basic instructions that you're gonna need to configure your high-speed counter. Also, I'll make sure that you have this down in the description because this will be key for you understanding how to wire it. And in our next video, we are going to really start breaking down these signals that we're getting from it and begin to understand them. Till next time. Hey, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!